give you an overview of the topics that I'll be discussing, first one is the expected return on a portfolio, second is portfolio risk, and the last one is the beta coefficient. In this section, we discuss the risk of stocks when they are held in portfolios rather than as standalone assets. Our discussion is based on an extremely important theory, the capital asset pricing model, or CAPM, that was developed in the 1960s. So what exactly is CAPM? Capital asset pricing model is a model based on our proposition that any stock's required rate of return is equal to the risk-free rate of return plus a risk premium that reflects only the risk remaining after diversification. Now we will discuss about expected return on a portfolio. So what is return on a portfolio? It is the weighted average of the expected returns on the assets held in the portfolio. Thus far in the chapter, we have considered the riskiness of assets when they are held in isolation. This is generally appropriate for small businesses, many real estate investments, and capital budgeting projects. However, the risk of a stock held in a portfolio is typically lower than the stock's risk when it is held alone. When calculating portfolio expected return, assume a two-stock portfolio is created with $50,000 invested in both HT and collections. A portfolio's expected return is the weighted average of the returns of the portfolio's component assets. Thus, 0.5 times 12.4% plus 0.5 times 1.0% is equals to 6.7%. Another example would be Table 8.4 that can be used to implement the equation. Here we assume that an analyst estimated returns on the 4 stocks shown in column 1 for the coming year, as shown in column 2. Suppose further that you had $100,000 and you plan to invest $25,000 or 25% of the total in each stock. You could multiply each stock's percentage weight as shown in column 4 by its expected return. Get the product terms in column 5 and then sum column 5 to get the expected portfolio return at 10.75%. Again, the key point to remember is that expected return on a portfolio is a weighted average of expected returns on the stocks in the portfolio. The next topic is portfolio risk. Portfolio risk is generally smaller than the average of the stocks because diversification lowers the portfolio's risk. Although the expected return on a portfolio is simply the weighted average of the expected returns on its individual stocks, the portfolio's risk is not a weighted average of the individual stock standard deviations. To illustrate this point, consider the situation in Figure 8.4. Stocks W and M can be combined to form a riskless portfolio because their returns move counter-cyclically to each other. When W's fall, M's rise, and vice versa. The tendency of two variables to move together is called correlation, and the correlation coefficient measures this tendency. In statistical terms, we say that the returns on stocks W and M are perfectly negatively correlated. As we see in the lower graph, we see that when stocks are perfectly negatively correlated, all risks can be diversified away. And in the upper graph, when stocks are perfectly positively correlated, diversification does no good. In reality, most stocks are positively correlated but not perfectly so. Past studies have estimated that on average, the correlation coefficient between the returns of two randomly selected stocks is about 0.30. Under this condition, combining stocks into portfolios reduces risk but does not completely eliminate it. In our examples, we considered portfolios with only 2 stocks. What would happen if we increased the number of stocks in a portfolio? As we see in the graph, portfolio risk declines as the number of stocks in a portfolio increases. Here are points to remember. The portfolio's risk declines as stocks are added, but at a decreasing rate. And once 40 to 50 stocks are in the portfolio, additional stocks do little to reduce risk. The portfolio's total risk can be divided into 2 parts. diversifiable risk, and market risk. Diversifiable risk is the risk that is eliminated by adding stocks. It is also known as company-specific or unsystematic risk. Market risk, on the other hand, is the risk that remains even if the portfolio holds every stock in the market. It is also known as non-diversifiable or systematic or beta risk. It is the risk that remains in the portfolio after diversification has eliminated all company-specific risk. Diversification comes when stocks are subject to different kinds of events, such that their returns differ over time. For example, if stocks' returns are not perfectly correlated, their price movements counteract each other. By contrast, if two stocks are perfectly correlated, diversification has no effect on risk. In conclusion, investors are only compensated for risks they bear. Any risks which can be diversified will not be compensated. Our last topic is the beta coefficient. Beta coefficient is a metric that shows the extent to which a given stock's returns move out and down with the stock market. Beta thus measures market risk. Beta also shows a stock's volatility relative to the market. It indicates how risky a stock is if the stock is held in a well-diversified portfolio. If beta is equal to 0, the security is just as risky as the average stock. If beta is greater than 1, the security is riskier than average. And if beta is less than 1, the security is less risky than average. Most stocks have betas in the range of 0.5 to 1.5. Can a beta of security be negative? The answer is yes, if the correlation between stock I and the market is negative. If the correlation is negative, the regression line would slope downward, and the beta would be negative. However, a negative beta is highly unlikely. In calculating betas, well-diversified investors are primarily concerned with how a stock is expected to move relative to the market in the future. Without a crystal ball to predict the future, analysts are forced to rely on historical data. A typical approach to estimate beta is to run a regression of the security's past returns against the past returns of the market. The slope of the regression line is defined as the beta coefficient for the security. In this figure, stock A is defined as an average risk stock because it has a beta of 1 and thus moves up and down in step with the general market. Thus, an average stock will, in general, move up by 10% when the market moves up by 10% and fall by 10% when the market falls by 10%. Stock H, which has beta of 2, is twice as volatile as an average stock, which means that it is twice as risky. The value of a portfolio consisting of beta 2 stocks could double or half in a short time. Stock L, on the other hand, with beta of 0.5 is only half as volatile as the average stock, and a portfolio of such stocks would rise and fall only half as rapidly as the market. Thus, its risk would be half that of an average risk portfolio with beta of 1. Thus, because a stock's beta reflects its contribution to the riskiness of a portfolio, beta is theoretically correct measure of the stock's riskiness. And that's about it. Thank you for listening.